First problem, maybe not so much, but after that, yes. All right. Now, looking at these two lines, the blue line and the red line, they look to be parallel. How can we tell if they're parallel or not? Check their slopes. Now, these are in standard form. A standard form equation is ax plus by equals c. Okay? To find the slope of a standard form equation, the slope is just negative a over b. Because if you solve for y, that's what you're going to get for the number in front of x is negative a over b. So we can just take negative a over b right now. So negative 3 over negative 9 is a slope of 1/3. Negative 2 over negative 6 is a slope of 1/3. What do we see? Same slope. Same slope means they are parallel. Being parallel means that they will never cross. And how many solutions will they have? None. Okay? If two lines are parallel, then they have no solutions. Now, for this, what we should do is we should graph them on the graphing calculator. Now, it would be great if the graphing calculator took this, but it does not. Okay, so we have to solve them each for y. So 7y equals negative 4x plus 31, and then divide by 7. So if we go y equals, and I'll clear out that, if I go y equals negative 4/7 x plus 31/7. That's my first line. My second line is y equals, so negative 5y equals negative 7x minus 32, and divide by negative 5. So y equals 5, or 7/5, 7/5 x plus 32/5. We graph them both. I got one line going like that, another line going like that, and obviously there is one solution. Okay? All you need to do is look at the slopes. Are the slopes different? Yes. If the slopes are different from each other, then there's going to be one solution. Now, where is that solution going to be? Well, to find it, we go second trace, and we find where they intersect. Enter, enter, enter. And they intersect at negative 1, 5. Okay, so I can skip over that. Okay, this one, which two graphs can I eliminate instantly looking at this? Looking at this function. Since x squared is positive, it opens up, so a and c can instantly be trashed. Okay? Now, the slope of this one is negative a over b, which is positive 1 over 4. So it should be going up at a slope of 1/4. So you know instantly it's this one. What's the solution? Well, I would graph these on my graphing calculator, find where they intersect. How many intersections are they going to have? 2. So you're going to have 2 answers here. Okay, you're going to have 2 answers here. Now, if P equals this and P equals this, and then the supply and demand curves, to find the equilibrium point, you graph them and check where they cross. So I have 16,600 minus 60x, and then 100 plus 50x. If we graph them both, ooh, I bet they won't even fit on here. Not very well. Okay. So if I change my window to like 500, 0 to 500, and 0 to 500, I'll see what I got going on now. There's one graph, there's another graph. Not even close yet. As far as the X's go, I'm fine. But as far as the Y's go, let's go to 50,000 just to see. And there we go. Okay. So then you go just second, trace, where they intersect, enter, enter, enter. And it's at a price of $150, which gives you 7,600 in, well, 107. I would suppose 150. Okay. P is first. So $7,600 is 150 units. Okay? Because P then X, I think, is what they do. Okay? A rectangle has an area of 36 and a perimeter of 30. Find the dimensions of the rectangle. Well, I know if it has an area of 36, X times Y equals 36. If it has a perimeter of 30, 2X plus 2Y equals 30. So I have to solve both of these for X, or for Y. So here, Y equals 36 over X. Here, if we divide everything by 2 and then move the X, Y equals 15 minus X. So if I put those in, 15 minus X, clear it, 15 minus X, and 36 over X. And I zoom 6 to get back to my normal window. Ooh, I don't quite fit in. So then I'll just change this from -20 to 20, -20 to 20. Okay, so my intersections are right here and right here because there's no intersections down there. So if I go close to this one and hit enter, 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 I get the intersection point at 312. And I bet over here it's 12.3. But second trace, 5. If I slide on over, I gotta get really close to it and then hit enter, enter, enter. And that's 12.3. So it really doesn't matter what X is and what Y is. It is just the smaller dimension in the first box, well, that's 3. The larger in the second box, that's 12. Okay. The next one, we don't spend enough time compared to back in the day on these. We spent a lot of time on these. A boat's crew rowed 18 miles downstream with a current for 2 hours. So this is a rate times time equals distance problem. Rate times time equals distance. And you're going downstream and then upstream. Now your rate, if you're going downstream, you don't know how fast you're going, but the stream is helping you. Okay? You're going for 2 hours and you went 18 miles. Going upstream, same distance, but your rate is slowed because you're going against the current, so it's x minus y, 4.5 hours, 18. So you multiply across, so it's 2x plus 2y equals 18 is your first equation, and then 4.5x minus 4.5y equals 18 is your second equation. First equation, if we divide by 2, x plus y equals 9. Second equation, if we divide by 4.5, x minus y equals 4, right? You wouldn't have to graph this. You just solve this way. 2x equals 13, x equals 6.